So it asked you to, I believe, approximate what was the fifth root of 2. Is that right? I believe that's what it was. So what I was intending for you to do is to write a polynomial equation that has that as its solution. And so a lot of people ask me, oh, well, can I just use x minus the root of 2 as my equation? Well, you could, but then your approximation using Newton's method doesn't make a lot of sense, because you already know it's the fifth root of 2. You already know. I mean, it's just a straight line, so it's just one iteration of it. So what I was hoping that people would do would be to write out a fifth degree polynomial, something like x to the fifth minus 2, y equals x to the fifth minus 2, and say, all right, we're looking for the x-intercept of x to the fifth minus 2. Because if you solve that, set that equals 0, what do you get? You get x equals the fifth root of 2. So I was hoping you would use Newton's method to approximate the root of x to the fifth minus 2. Does that make sense or no?
Yeah.
Yeah, so you would have ended up using the formula x sub n plus 1 is equal to x sub n minus, and then x sub n to the fifth minus 2 over 5 x sub n to the fourth. And then you would have just, chose a value for that. So, if you plug in 1 to that, it's negative. If you plug in 2 to this, it's positive, right? So we'd say f of 1 is -1, and f of 2, what is f of 2? What's 2 to the fifth? 32 minus the 2 is 30. So you know that since this is continuous, the IDT says that there's a root on the interval 1 to 2. So pick something like 1.5 and then plug it in. Do you want me to plug it into the calculator and do it, or are you good with that?
I'm good with that.
Okay. Anybody else have anybody else want me to plug it in and show it, or any other questions on the homework from last night?
I have a question when writing our answer for it. So for my answers, I just put like x4 equals x5 equals the answer, and I didn't like write out every single value that I got in my calculator. I just kind of wrote that like I got the answer twice, and then I put the answer.
Yeah, I mean, I'd kind of like you to write them out, but if you didn't, it's not that big a deal. What I really want to see is that you got 2 iterations that were the same, that you have the correct formula that you're using, and that you had some reasoning behind your first guess, unless it was I already gave you an interval to check on. So if I didn't give you an interval to check on, I'd like to see the reasoning and the formula. If I gave you the interval, I'd just like to see the formula, and then your first value and your last couple is fine.
Okay, thank you.
Yeah. Any other questions on last night's stuff or no?
I had a quick question on number 3.
Okay.
Just because like I was wondering why some values work and then others don't, because I used like 1.7 to try to plug it in, and then the number just kept increasing. But when I plugged in 1.5, like it zeroed down to like a number.
Let's see, which one was that?
That was tangent of x equals e.
Okay, yeah. The most likely reason on that is because that's got vertical asymptotes on it. So you would have had to have picked a number that was fairly close to the actual value. You said you tried, let's see, because there's an asymptote at pi over 2. What did you say? You tried 1.7?
Yeah.
Yeah, so if you try 1.7, that's beyond that first asymptote. Well, let me think about this actually for 1 second. Let me graph it and look at it real quick. But let's see, tangent x. Yeah. The reason why is because that the asymptote's at pi over 2, and pi over 2 is less than 1.7. That's the reason why that you didn't get one on the. I was asking for one on an interval from like 1 to 2. Is that right?
Yeah.
Yeah, that's the reason why. It's because it was beyond that first vertical, or not that first, but that vertical asymptote that divides it at pi over 2. And so it ended up increasing beyond where you want it to be. You had to pick something for that one. You had to pick something that was pretty darn close to it, actually, because the ends of that, if you pick something close to the ends of it, where it's close to that vertical asymptote, the slopes are so steep that it doesn't come back around and hit something close by. It hits something like below way below again, that ends up skewing it horribly. I won't give you one on a quiz that has an issue like that for sure. So don't stress about that too much.
Okay, thank you.
But that's the reason why. It's because of those asymptotes.
Can you use pi over 2 for that one if you do tangent, inverse tangent E equals x? Like if you change it to inverse tangent E equals x and then inverse tangent E minus x?
Sorry, what do you want? You want to take it? You said x equals inverse tangent of E, and what do you want to do with that?
And then I got an answer from plugging in for my first value, pi over 2.
Let's see. So then I'm not sure what you're saying you did though.
Well, then I just made that equation that you have equal to 0. So it was inverse tangent of E minus x.